Hi, I am.
Hi, I am.
Hi, I am. Hi everyone. Today I am going to teach you on how to write complex number in rectangular form. So basically we know that complex form is in the form of a plus bi. So for the rectangular form, x plus yi. Therefore, the question said that write 6 plus square root of negative 16 to rectangular form. Then we all know that I square is always equal to negative 1. For the step 1, from the question 6 plus square root of negative 16, we only take this negative 16 to here and we separate the negative from the 16 and make it into this. Then we got calculate from square root of 16, we got 4 and negative 1 is always equal to I. So the answer we got 4i. And then for I, we bring forward to this. From the question, we got 6 plus square root of negative 16 and the final answer is 6 plus 4i. So the next lesson is on how to write complex number in polar form. So basically we know that to find modulus, we must use square root of a squared plus b squared. This one is the formula for polar form. A plus bi equal to r cos beta plus I sin beta. A plus bi, the value of r must less than the value of beta. So we go to the question. How to convert 6 minus 3i to polar form? So for the first one, we must extract the value of x and y from the equation, which is x equal to 6 and y equal to negative 3. Step 1. Find modulus. Find modulus, we use the formula of this and put in the value of x and y, 6 squared plus negative 3 squared. And then we calculate it and get the 36 plus 9. The total value is equal to 45. And calculate it again, we get 6.71. And for the step 2, find the argument. We use theta tan negative 1 equal to b bracket b over a. We get negative 26.57. So we can get the polar form from the equation here. The polar form of 6 minus 3i is about 6.71 bracket cos theta plus I sin theta.
Lesson is to find modulus and argument. To find modulus and argument, we use this formula. To find modulus, we use this formula, and to find argument, we use this formula. The question, we find the value of x and y. X equal to negative 7 and y equal to 6. So step 1, we plot the graph for x and y. And after that, step 2, we find modulus. We use this formula and insert x and y to this square root, and then we calculate, and the answer is 9.22 units. And find argument, we use this formula. So we just put value of x and y to the formula and calculate it, and the answer is negative 40.60. To find theta, we see from the graph, this graph from step 1, and the graph shows quadrant 2. So we use this formula for quadrant 2, and the formula is theta equal to 180 minus a. So we just put the value from this argument and we put here. So the final answer is 220.6.
Alright, good morning everyone. So today we're going to talk about plotting a graph of a complex numbers. So the question we have here is z equals to 2 plus 3i. So we want to know first which one we have to decide which number we can put into the y-axis and the x-axis. So we have here is the complex number in standard form. So the a is the real number and bi is the imaginary number. So to put it into the graph, the real number should be on the x-axis, the horizontal axis, and the imaginary number is to be put on the y-axis. So going back to the question, so the real number is 2 and the imaginary number is 3i. So, okay, sorry about that. So the number 2, which is the real number, should be on the x-axis. So you have to plot it over here. And then the imaginary number, which is the 3i, you have to plot it here. And once you get the number from the question, so plot it right over here, and then you will get this. For the next lesson for today is the operation of complex numbers for divisions. So before we starting solving the question for today, so you have to know two things. So first of all, the complex number standard form, which is a plus bi. So the a is the real number and bi is the imaginary number. You always arrange in such manner. So secondly, I squared is actually one of the number that we want to look out for, which is the I squared is equals to I1. So the question for today, given that Z1 is 1 plus 2i, and Z2 is 2 plus 3i. So the question here is to find Z1 over Z2. So first of all, we arrange it in this manner. So Z1 over Z2 equals to 1 plus 2i over 2 plus 3i. So what we want to do next is to multiply these two numbers, two complex numbers, with what we call conjugate, which is 2 over 3i over 2 minus 3i over 2 minus 3i, which is the negative for the denominator. So what we want to do next is to actually expand it to the other side. And we finally got this one. So you multiply everything. So afterwards you get this one. And when you further rearrange it and add up all the numbers, so you got a plus 7i over 4 over 3, 4 plus 3, and then you add it up all together. And one thing I forgot to say is that you might notice that minus 6i plus 6i. So what happened is actually cancel out each other because it's equals to 0. So you got a plus 7i over 4 plus 3. So this mistake here, just ignore it. Right? When you add up the denominator, 4 plus 3 is plus 7i over 7. And then you separate it together at plus 7 plus 7i over 7. And again, you have to remember the complex form standard is that the real number should be in front and the imaginary number should be on the back. So it equals, rearrange it again at 8 plus 7 and plus 1i, which is from 7 over 7, which equals to 1. So that's all for me. Thank you.
That is all from us.
Thank you.